Welcome to Unit 2, Chapter 4. It's a little strange, we're going to be jumping around, but what we're getting into now is trigonometry. So we're going to start trigonometry with the introduction of radians and the unit circle, but mainly this chapter, what you need to know are the objectives below. And the objectives are to understand what a radian is, right? That's the main thing. You want to walk away with a firm understanding of what is a radian. The other thing is you need to be able to convert radians to degrees, degrees to radians by the end of this video, and then just know and maintain some of the vocabulary that I'm about to introduce. So this first slide, I'm confident that you can kind of figure out it's mostly review. But the big thing is we have an initial side and a terminal side, two pieces that make up an angle. And standard position, this would probably be the newest thing to you. What we always do is we will put the initial side on our x positive axes, and then we'll open up that angle from that position of the initial side. So somewhere our terminal side will be opening up from that positive x axis. More vocabulary. These ones are a little new probably. Positive angles, when we're talking about the standard position of angles, if you have your axes, okay, and again you have your initial side sitting on the positive x-axis, so right there, a positive angle is going to move counterclockwise. Think of a positive angle. They're going to be flying in the sky. So there's that. Okay, so that would be approximately, we'll say 135 degrees, and that's positive. Versus a negative angle, if you're going to have a standard form angle or a standard position angle, you're going to again start on that positive x-axis with the initial side. And then this is a negative angle, so it's a dark angle. It goes down below, and then it might come back up. But here we have something like that. Okay, so that would be the same thing as about 225 degrees, okay, and that would be negative, okay, because we went in the clockwise direction, down below. This is our new one. Radians are going to be a unit of measurement for the arc length around the circle, around a circle's circumference. There's 2 pi radians total in a circle. Here's a quick analogy. A radian, once again, all it is, it's a length. It's a way of measuring, so we need a set length. So an analogy, radians are to circle to a circumference as my foot is to my body height. So you could take a piece of me and then measure my height with that piece. So there's me, and then there's my foot, and there's about 7.5 of my feet that would go up my body length. Okay? So same thing with radians. I mean, take a piece of the circle, which is the radius, the center to the end, and what you're going to have is about 6 and then 0.28 of those. 2 pi, we sometimes lose the fact that it's a number, and that would just be 2 times 3.14, so it's approximately 6.28. Okay, and that should make sense because we've always said that the circumference is 2 pi times whatever this length is, but now we're just saying just let it be a radian. Who cares really what length it is? I just know that 2 pi of these will fit around my circle. And we have a video of our 4th period pre-calc class figuring that out.
Come here. Come on.
First task, figuring out how many radii fit around the circumference of the big circle.
Okay. Make sure it's center. Right. No, don't make it too right. Just regular.
Is that the center?
Yes. Oh, straight. Okay.
There's one.
You guys want to make a bunch of those or just swing around? Just swing around. All right. Call and swing. Swing. Don't keep it tight. Okay. Okay. Gotta go loose. Let go loose. All right.
Is that curve around the thing?
Oh, I got you. Perfect. I think you might be.
Okay.
Make sure it's in the, kind of in the center. Do some more. Do some more. Time a little bit. Is that good? 1. Colin, hold. Two. Good. 3. One more.
What'd you say?
Nothing.
What'd you say?
Nothing.
What'd you say?
Okay, 4.
What'd you say?
3.14. 5. 6.
And a half. Or like
6, I'm going to say point 28. Right?
How many? How many radii?
0.28.
Huh.
I just changed my clothes. Whoa. Okay, so we have accomplished, hopefully, objective number 1 in understanding what a radian is. Now we need to do objective 2, which is convert between radian measurement and then degree measurement. 2 different ways of measuring. So here we do know now that all the way around the circle there would be 2 pi radiuses that would fit around. So here are our radian side. And then 360, that's our total degrees around the circle if we were to open from the inside of the circle versus walking around it. So we know that these are proportional now because what you could say is, I mean, as you increase walking around the circle, your degrees or your angle is going to open up longer as well. So let's do some examples on how to convert using this proportion that we just set up. So write each angle in a radian measure as a multiple of pi. Not the most clear instructions, but what they're saying is we're going to just write this angle of degrees in radian measurement and you're going to keep the pi in there. So let's go ahead and try this. We're going to go and fill in what we know. We do know that we have a certain amount of degrees out of 360, and then we want to figure out relative to 2 pi, what would that be? Right, so way long ago, you learned a property that states that if you ever have proportional fractions, such as these, you can call them equal, and also a property states that the cross products are equal. So if you multiply those, they're going to be equal to the multiplication of 2 times 3, and you can see that is clear. So that's a property that we know about proportions that we're going to use here as well. We have 30 times 2 pi equals 360 times r. So we are trying to get this r by itself now. So I'm going to divide both sides by 360, both sides by 360, and I'm going to do a weird reduction here. I'm going to just reduce this at first. So we're going to get, divide each by 2, so you're going to get 30 pi over 180 is equal to our r. So now this does reduce further, and I'll go ahead and do that. Both of those, top and bottom, are divisible by 30, so I'm going to divide by 30. What we're going to get is pi over 6 equals r. So if we were to approximate that, though it says to keep the pi in, this is 1/6 of that 3.14. If you did this in your calculator, you're going to get approximately 5.2 radians. Okay, so all we're saying is you could look at your circle and open from that standard position, here's my initial side, and open up 30 degrees, okay? Or you could have said this would be the equivalent of walking about a half of a radius length around the circle. So that would be approximately half of the radius, and it would line up with this arc length right there. Okay, so let's do another one. We have 150, this time over 360, equals r over 2 pi. So again, we're going to cross multiply and set them equal, and then we're going to solve for r. So I'm going to do that weird thing where I'm just going to reduce this at first. We get 150 and then pi over 180 equals my r. And then so if you were to reduce this further, I'm going to divide the top by 30, which means you'd have to divide the bottom by 30. We're going to get 5 pi over 6 equals r. Okay, so that would be the same thing. We would have 5/6 times pi and then radians around our circle. Okay, another way to look at that would be kind of like this. If you were to divide this pi, remember this would be pi, into 6 equal pieces, and I know that's pi because all the way around would have been 2 pi. But if you divide it into 6 pieces, we have 5/6, so 1, 2, 3, 4, 5 sixth of pi. That's where this angle would approximately be, and we know that's the case with 150 degrees. Alright, so this leads me to another ratio that you could use that's a little bit more simplified. So knowing now that we could have used 2 pi and 360 because they're proportional, they're the same amount. Same as with pi and 180. So that's going to just be right sitting here, so we can use this proportion as well. Either one of these work just fine. So I'm actually going to start using this for these problems down here where we're going to now know the radians and we're going to want to find the degree measurement. So this time I know the r and I'm trying to find the d, so here I'm going to go with that. And keep in mind this negative, all that means is we're going to be opening in the clockwise direction for an angle like this. So we would be moving clockwise. So now we have 7 pi over 12, and so again what I'm doing is I'm going to be filling in this, and this is going to be over pi, equals, and then d, my unknown, over 180 because I don't know my degrees. So I am just going to go multiply my cross products, and then pi over d. So I'm going to do, instead of dividing by pi, I'm going to multiply by 1 over pi, so multiplying by the reciprocal, which will cancel those out, and this will become 1 over pi. So now if you multiply all of this straight across, what we're going to get is negative 7 pi over 12 times, and if you gather those together, you just multiply tops, multiply bottoms, it's 180 over pi, over pi. So these pi's cancel each other out. So what we get is d is equal to negative 7 times 180 over 12, and when all of that is said and done, we're going to get is equal to negative 105 equals d. So there's that. Alright, and then finally let's do one more. We're going to do pi over 9 is all over pi equals, and then we have d over 180. So now that's going to lead us to the pi over 9 times 180 over 1 equals d times pi. Again, I'm going to multiply by 1 over pi on this side. So I get pi over 9 times 180 over pi equals d. And then these cancel each other out. I can divide both by 9. So what I just get is 20 degrees equals d. And sorry, I forgot my degree sign over here. So now that leads me to this thing right here. This is what your book uses, converting between radians and degrees. So sorry about my marks. So what it does is it says that if you were ever getting a degree amount and you wanted to change it to radians, just multiply that given degrees by pi over 180. And you can see that that's what I did here. Here was my 30, and I multiplied it by that pi over 180. Okay, so then we would have gotten this as well. Same thing here. Here was that 150 degrees, and I multiplied it by that pi over 180. Down here, if you have radians, you can take the radians amount. So you can see I had my radian amount right here, the negative 7 pi over 12, and I multiplied it by 180 over pi. Okay, that's what this is saying. Same thing over here. I had my pi over 9, and I multiplied it by my 180 over pi. Okay, so either way, if you use this or the conversion methods, I personally prefer these because on the test you might get mixed up and be like, is it pi over 180 I multiply or 180 over pi? And then you get stuck and then it's over. Okay, so here are your practice problems. Number 7 and 8, I'm going to be interested to see what you do because they're asking you what quadrant it is and they only give you the radian measurements. So I'm going to be curious how you tackle those. Good luck!